Welcome to Precalculus Concept 1D sequences using summation notation. There are 4 boxes, so let's get started right away. So let's talk about the idea of summation notation. And all it is a nice way to write the sum of a finite or an infinite sequence. We're talking about sequences here, and this notation that I'm going to show you is a really nice way in which we can write them, okay? So there's a couple of things that we have to learn on how to read summation notation. So first of all, summation notation starts with this symbol here. This is the symbol, the Greek letter sigma, S-I-G-M-A. This is the Greek letter sigma, S-I-G-M-A, which is why this is called summation notation or sigma notation. So whenever you see this symbol, you are going to be thinking of one thing. When you're going to see this symbol, you're going to remember that this symbol means to add stuff up, okay? Whenever you see this symbol, it means you're going to add some stuff up, okay? Now there's 3 parts for when you're going to be adding some things up. You need to start somewhere, you need to end somewhere, and then you also need to know how exactly you're going to add these things up. So here's how we do it. So we read this by saying, okay, I have a sigma notation, so I'm going to be adding things up. This part down here, I equals something. This is going to be where we start, okay? And I'm going to explain all this once you see a couple of examples. But this is where we start, okay? This tells us where we're going to start adding when I is equal to 1. Up at the top of the sigma, it has the ending place. In this case, I'm just going to use the variable n. So this is where we end. So we have a starting point, which is denoted by the thing on the bottom, and I have an ending point, which is denoted by the thing on the top, and then I have the sequence defined a sub I. This is sort of the how we're going to do it, how we do it, okay? So what this means is I take a sub 1, the value of a sub 1, and I add it to the value of a sub 2, and I add it to the value of a sub 3, and I keep going until I reach the value of a sub n, because it tells me where to stop. So this is a very, very broad definition of what we're going to be doing for learning how to read summation notation. So let me give you an example here and how we would read this together, okay? So let's say something like this, okay? So if I take a look over here, this says I want the sum as I goes from 1 to 3 of 2i. I want the sum as I goes from 1 to 3 of 2i. That's how we read that. The sigma part tells me the sum, the I part down below tells me where to start, the 3 up at the top tells me where to end, and the 2i tells me how we're going to do it. This is what we're focusing on for this concept. Okay, box number 2, I'm going to show you 3 examples of how to expand and evaluate a sum. So example A, I have the sum I goes from 1 to 4 of I squared plus 1. So I really want you to have a solid understanding of what this means. This means starting with 1, plug it in and evaluate. So this would be 1 squared plus 1, okay? Then I would add that 2 and count up from my index. So index goes 1, 2, 3, and then 4. So then I would do 2 squared plus 1. And then I would add that to 3 squared plus 1. And then I would add that to 4 squared plus 1, and then I would be done. So I'm taking each index and I am plugging it into my sequence 4 times. So starting with an index of 1 and counting up to 4. So index of 1, 2, 3, and then 4. This is what it means for summation notation. Once I have all this, all I have to do is clean it up. 1 squared is 1 plus 1 is, this is the number 2. 2 squared is 4, 4 plus 1 is the number 5. 3 squared is 9, 9 plus 1 is the number 10. 4 squared is 16, 16 plus 1 is the number 17. So then all I have to do is add these up together. So 5 and 2 make 7, and 10 make 17. 17 and 17 make a grand total of 34, and we have completed example A. Let's take a look at example B. Now this has a k down here. That's okay. It doesn't have to be the letter I. You can use any variable you want. So k goes from 4 to 7 of negative 2 to the k minus 5. So we're going to evaluate, and then we're going to expand and evaluate. So the first one is I'm going to have negative 2 raised to the 4th power, because notice it's telling me to start with a 4. and then subtract 5. Okay, I'm going to add that to negative 2 to the 5th power, and then subtract 5. And I'm going to add that to negative 2 all raised to the 6th power, and then I'm going to subtract 5. And then I'm going to add this to negative 2 to the 7th power, and then subtract 5. And I know that I'm starting at the number 4 and I'm ending at the number 7. So that's what it means to expand it. Now all I have to do is clean those all up, okay? And I'm going to go ahead and use my calculator to help me clean all these up here. Okay, using the calculator, I see that this whole expression right here has a value of 11. I see that this whole expression right here has a value of negative 37. I see that this whole expression right here has a value of 59. And I see that this whole expression right here has a value of negative 133. And what am I doing to all of these things, everybody? I'm adding them all up. So when I add them all up, I get a value of negative 100. Okay? So this whole expression right here has a value of negative 100. Okay, example C is a little bit different. This says I goes from 1 to 5 of a constant, the number 3. So what this means is the very first term is just the number 3. The very next term is the number 3. The very next term is the number 3. The very next term is the number 3. And the last term is the number 3. This is simply 5 values of the number 3. So basically, whenever you have a constant out in front of your sigma, you're just going to multiply the constant times the n. So 3 times 5, so this is just a value of 15. That one's pretty easy. Okay, box number 3 is a U-try. Go ahead and expand and evaluate the sum. Hopefully you got the right answer. You should have noticed that this means 2 times 1 squared plus 2 times 2 squared plus 2 times 3 squared. So this expression has a value of 2. This expression has a value of 8. This expression has a value of 18. So therefore, when you add them all together, you get a value of 28. Okay, box number 4 is an express using summation notation going in the opposite direction here. So we're going to take an expanded sum and we want to write it using summation notation. So notice I have 1 to the third plus 2 to the third plus 3 to the third plus dot 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 plus 7 to the third. So if I was going to go in reverse order, I would write down my sigma notation. I'd say I has to start with the number 1 and it ends with the number 7. The reason I know this is because I'm looking here and then I'm looking here. So I started at 1 and then I ended at 7. And then you got to ask yourself, what is it that we did? Well, all we do is we take each value and we cube it. So this is just the value of I cubed. So this is nothing more than the sum 1 to 7 of I cubed. Okay, take a look at part B, last one here. I have 1 plus a third plus a ninth plus a 27th plus dot 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 plus 1 over 3 to the n minus 1. Well, I know I'm going to have a summation, and I know that I is going to start with 1 because I see it here. There's a value of plugging in a 1. But this one ends at the value of n, and the reason I know that is because I'm looking here. It just says 1 over 3 to the n minus 1. Well, so I'm going from 1 to n, and this is exactly how I get each of these terms. It is 1 over 3 to the n minus 1. That's all you have to do for this one. This is how we would write it. So you can test this and see, right? If I wanted this term, for example, it's the third term. So if I were to plug in a value of 3, I just realized that this should be 3 to the n minus 1 in the exponent like that. So this was supposed to be 3 to the n minus 1, not the minus 1 on the outside. So anyways, for the sigma notation, we would go from 1 to n of 1 over 3 to the n minus 1. So as an example, if this is the third term, if I plug in a 1 over 3 to the 3 minus 1, I get 1 over 3 squared, which gives me the 1/9. So when you have a problem like this, all you have to do is figure out the starting point, and the ending point is just simply an n, and how you do it is located at the end.